Today I will present a project where I analyzed stroke-related health data. Stroke is one of the world's top causes of death. If we can predict stroke early, we can help save lives. So my goal is to find patterns in the data and predict who is at risk. The dataset includes over 5,000 patients' records. The target variable is binary, which is stroke cases or non-stroke cases. It's an imbalanced dataset, meaning we have the most cases which people didn't have a stroke, and it makes prediction and analysis challenging. We clean the data by removing unnecessary features like ID, mapping binary categories into 0 or 1. In the gender column, there were one entry labeled order. Since it was just a single row, it wouldn't provide meaningful insights and it could confuse the model and analysis, so I decided to drop that one record to keep the data consistent. So after data cleansing, we moved to the analysis part. So let's start with age. We can clearly see that stroke cases rise sharply between age 65 to 80. In contrast, people without stroke are mostly under 60. This tells us that as people get older, especially after 60, the risk of stroke increases quite significantly. Also, stroke patients had slightly higher BMI, but non-stroke cases has more extreme BMI value. However, when we look at glucose level, stroke patients had both higher median and wide range. So high glucose is more strongly related to stroke. Besides, I created a correlation heat map to see which numerical features most related to stroke. Age is the most important, followed by health conditions like hypertension. Gender, residential types, and marriage status showed very low correlation. Next, we take a look on stroke rate on categorical features. To calculate stroke rate, we divide the numbers of stroke cases by the total people in each group. So interestingly, people who used to smoke had higher stroke rate than current smokers. That may be because the damage from smoking builds up over time even after they quit. So for the work type, people who are self-employed had more stroke than those in government or private job, which may relate to the stress or less access to regular health care. So children and those who never worked had almost no stroke case, probably because they are younger and less stressed with their work. So to wrap up first, I found that the most important factor is age. Stroke risk increase significantly as people get older, especially after 60. Glucose level and hypertension also stood out as strong predictors. People with higher glucose and high blood pressures were more likely to have a stroke. So we also looked into lifestyle factors like smoking habits and work type. So people who used to smoke had a higher stroke rate than even current smokers. So that may because the long-term effects of smoking may continue to impact health even after quitting. So for the work type, we saw that self-employed individual had a highest stroke rate. This may because of the higher stress level, less stable access to the healthcare or irregular routines compared to the one who works in governments or private employees. So on the other hand, demographic features like the gender, marriage status, or like where they live didn't show a strong relationship with stroke when looked at the alone features. So next we move to the machine learning prediction part. So our primary goal is to predict stroke risk and understanding key contributing features. I chose classification models because our target variable is binary, and we use both logistic regression and decision trees for prediction. We started by separating our target variable stroke from the other features first. Next, we split the data into training and testing sets using an 80-20 ratio, while making sure the class distribution of stroke cases is preserved through stratification. We used the get dummies to convert categories like the work type and smoking status into numeric columns. Next, I handled the missing values issue in BMI. I used the simple imputers with the median strategy to fill them. Median is more robust to outliers compared to mean. The imputer was fitted only on a training set and they applied to both training and testing sets. This is to prevent any data leakage. Next step, I used the standard scaler to ensure that the data are transformed to have a balanced scale and it only fits to training data to avoid any data leakage. To train the model, I set class weight equals to balanced in both models. This tells the model to give more weight to the minority class since the data set is imbalanced. So now let's take a look at how the two models performed. While the decision trees has slightly better accuracy at around 80%, the number alone didn't tell the whole story because it is an imbalanced data set. So especially the stroke cases are so rare in this data set too. So we can take a look on the score on recall, which measures how well the model catches actual stroke cases. So in the recall, logistic regression performed much better with a recall of 82% compared to just 66% of the decision tree. And we can also check the ROC-AUC score, which reflects how well the model can tell stroke cases apart from non-stroke one. Against it, the logistic regression came out on the top with a score of 0.86, while the decision trees only scored 0.78. So overall, even though the decision trees had slightly higher accuracy, the logistic regression is clearly better at detecting stroke cases, which is exactly what we care about in this prediction model, in this prediction task. So for the importance features, both models agree that age is the strongest stroke predictor. So for the logistic regression also highlights hypertension and heart disease. The decision trees give more importance to BMI and glucose. So this shows how models weight features differently. So there are some limitations for this project. One of the biggest challenges is this project with the imbalance in the dataset. Only around 5% of the patients actually had stroke. That makes it tough for the analysis and training model because it's easy for model to just predict the long stroke cases and still be mostly white. But the most important things in the real life is we want the model to catch as many actual stroke cases as possible without too many false alarms. So this is one of the limitations. The other ones is there were also some missing and unclear value like the BMI columns, and some records had unknown in smoking data that may confuse the model. And there's another limitation is there's no timeline to see how a patient's health changed before or after a stroke or a lifestyle changes. So yeah, it could be a valuable values or features for prediction too. So overall, this project showed that even with simple features, we can find meaningful patterns in stroke risk. And with better data and tools, we could support earlier detection and help prevention in real-world setting too. So this is all my presentation. Thank you.